I see 3 sine x minus 4 cos x in this form, sometimes known as harmonic form, where r is greater than 0 and alpha is between 0 and 90. Okay, this is a little bit of a complex topic when you first see it, but once you've practiced it, it is a routine that you can learn and be able to apply. So we've got our addition formulae, and I want to be taking the bottom rung with the minus. So I'm going to let 3 sine x minus 4 cos x be identical to r sine x minus alpha. That's how I'm going to try and write it. And then I can expand that sine x minus alpha. So I'll get, and I'm just going to write the thing here basically, but with a replaced by x, the b replaced by alpha, and I'm going to be timesing through by r. So r sine x cos alpha minus r cos x sine alpha. And now we can, in this expanded form, compare the coefficients because we've got a sine x here and a sine x here. Therefore, it must be that r cos alpha is equal to 3. And then in a similar way, cos x here and cos x here. So it must be that r sine alpha is equal to 4. Yeah, I'm now going to draw a little right angled triangle. Put an alpha there. And I could rearrange the top one to give me cos alpha is 3 over r. And I can label my adjacent 3 and my hypotenuse r. Very similar with the sine alpha. It's 4 over r, so the opposite is 4. And it all works out really nicely from here. To get r, you basically square the numbers here, but this is y. So 3 squared plus 4 squared square rooted, which actually gives 5. So 3, 4, 5 triangle. This is called a Pythagorean triple, but by all means put it in your calculator. And then we use, well, I could use any of them now, but you typically use tan alpha, just in case we miscalculated r, which is going to be 4 over 3. So alpha will be inverse tan of 4 over 3. We're working in degrees, remember? Gives 53.130. Right then, therefore 3 sine x minus 4 cos x is identical to 5 sine x minus 53.1. Oh, sorry, alpha is meant to be to 4 significant figures, so 53.13. So for part B, we're then asked to hence, and that's the key word, hence solve this equation. So we don't want to use the left-hand side as it is, we want to use our harmonic form. So using part A, solve instead 5 sine. I always think we should use the non-rounded version, although in this case, because there's a 0 there, we can just go with it, 53.13, because I'm going to give my final answer to 3 significant figures, so there's enough, we've got enough accuracy. So that there is going to equal 2. It's between 0 and 90. So I didn't make a note whether it includes any of them. It doesn't. I don't think that's going to matter. So sine x minus 53.13 equal 2/5. Now I'm first of all going to solve for x minus 53.13. So we'll get into that kind of routine and work out this adjusted range. This one's going to be 36.87. Then we'll do inverse sine. That's a very small range. So actually, I believe we're only going to find one value. So 23.578 there isn't going to be a negative value that we then add 53 onto. And if we do 180 minus 23, we'll get something that's already gone beyond 36, also 90. So that is actually going to be our only solution in this case. We just need to add on the 53.13. To give 76.708 or 76.7 degrees to three significant figures.